Yeah, this is Ken Roseberg. We're going to talk about this geometry lab. We spoke in class how a circle may be defined by its center and a radius. If you know a center point and a radius, then every point that is that distance away from the center is on the circle. Okay? Or it can be defined by a point and its center. Well, if you have a center and a point, well, you've defined the radius, and therefore, if you've defined the radius for one point, you've defined it for all the points. Or alternatively, by a system of 3 points that mark out the circle's edge. Now, with this system, it's not as obvious as with this one where the center is, because the center is not given. So to write the equation of a circle, we know that we need a point, or which is the center, h comma k, and we need the radius. So how are we going to go from 3 points to finding the one point, which is the center and the radius? Well, what we know is that the center has to be equidistant from all three of these points. So a way of finding it involves geometry, which says first we got to find the perpendicular bisector of a chord. When we find the perpendicular bisector of a chord, any point on this chord is equidistant from both of these points. Okay, so it's equidistant from this point and it's equidistant from that point. Why? Because it's on its perpendicular bisector. Um, the midpoint is on the perpendicular bisector, um, and it is equidistant from these, but not just those. In both directions, any point that is equidistant from both of these points will be on the perpendicular bisector of this chord. Why am I calling it a chord? Because those are 2 points on the edge, and any line that connects 2 points on the edge of a circle is called a chord. And you can see that if I had a properly drawn circle, let me see if I can't draw a proper circle here, that if I take, let me just take 2 points on here and connect them with a line, and if I perpendicularly bisect that line, I find the midpoint, and I cut through it at a right angle, the center should be somewhere on that line. Of course, this isn't perfectly accurate, but it should be somewhere on there. Now, the thing is, one line is not sufficient because it could be anywhere on here. And that's why I need at least 3 points, because if I come along and I have another set of points and I perpendicularly bisect that point, I find the midpoint of that chord and draw that perpendicular bisector. Now I know um, that every point on this line is equidistant from these 2 points. Every point on this line is equidistant from these 2 points. So therefore, every every point, or this point here in particular, is equidistant from all 3 points, and that makes it the center. So that's how we find the center. We have to go through a process which involves a couple steps. First of all, we got to find the midpoint of the chord that we're working with. We have to find the slope of that chord. In finding the slope of the chord, we can then negate it and invert it, making it its negative reciprocal, which would be the slope of its perpendicular bisector. So we have to find the slope of this guy based on the chord. And then lastly, if we have a slope and a point, we can define this line as an equation, and the same thing over here. So if we have the equation for both lines, we can do a system of equations. So we'll have two equations, and the solution to the system will be the center. Once you know the center, you can use distance formula to find the distance there. That'll be the radius. And if you know the center and the radius, then you can write the equation. So that's basically this lab in a nutshell. The following instructions will guide you through a process that will lead you to the circle I took your points from. As you go through the process, you will have to print off certain results you get using the equation grapher program in, I should say, in green globs. There are a couple things you need to know, and they'll be in the next video. All right.